Welcome back. Problem 11-54. So statement is the overhang beam is constructed by using 2-inch by 4-inch two pieces of wood braced as shown. If allowable bending stress is 600 psi, determine the largest load P that can be applied and determine the associated maximum spacing of nails along the beam section of EC. If nail can resist a shear of 800 pound, assume the beam is pin connected at A, B, and D. Neglect the axial force developed in the beam along DA. So you can see this is the beam that is constructed of 2-inch by 4-inch of two pieces. Clear? And there is a point loading at P. So you have to find the this P. Clear? For safe loading, and you have to find this nail spacing as well. So let's start with the solution. So you can see that here the maximum movement will be at this point A will be equal to 3P, or if you cut the beam at this section and draw the draw the free body diagram. So this is point P. Clear? This is a length of 3 feet. So definitely you will be having a shear force V and you will be having a movement which will be the maximum movement. So shear force, sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So V minus P is equal to 0. So from here you will get V is equal to P. And we will find moment that sum of all moment about 0.1 must be equal to 0 and taking the counterclockwise moment is positive. So minus M plus P into 3 is equal to 0. So from here you will get moment which will be maximum moment will be equal to 3P, and the unit will be pound into feet because the length is in feet. Now we will move toward section properties, because section property is I. Section property is I. So if you draw the beam there, so let me draw it like this. Okay, so this length is 4 feet 4 inch, and this neutral axis will be at the mid. You can just move toward the mid, zoom. Okay, so this height is 2 inch and this height is also 2 inch. Clear? So I for this rectangular cross section is equal to 1 over 12 BH cube. So B is 4 and H is also 4 cube. So it will be equal to 21.33 inch power 4. And what about C? So C is equal to 2 inch. This is equal to C is distant from neutral axis till top or bottom. So section modulus S, which is equal to I divided by C, will be equal to 21.33 divided by 2, and that will be equal to 10.67 cubic inch. Now we know that section modulus is equal to maximum bending moment divided by allowable bending stress. Clear? So from here you will get maximum bending moment is equal to S into allowable stress. So maximum bending moment is 3P. So 3P, if we convert it into inch, so unit will be pounds into inch, and we will multiply it with 12 is equal to 10.67, which is the S value, and allowable shearing stress, allowable bending stress is 600 psi. I will show you. This is 600 psi. Okay, so when you solve this, you will get P is equal to 10.67 into 600 divided by 12 into 3. which is equal to 177.78 pounds, or P is equal to 178 pound. Clear? So this is the load that can be applied. Now for part 2, which is used to find the nail spacing. Clear? So we know that shear flow, which is Q, is equal to V into Q divided by I. Clear? So we have V, which is equal to P. V is equal to P, which is equal to 178 pounds. We'll show you V is equal to P, that is 178 pounds. Clear? And what about Q? So Q for this beam. So this is half, this portion is, this is 2 inch and this is 4 inch. So this area will be equal to 2 into 4. Clear? This is A dash. And what will be Y dash? So Y dash is distance from neutral axis till mid of this, which is equal to 2 divided by 2 and 1 inch. So 1 dash. So Q is equal to A dash into Y dash bar. Clear? So it will be equal to 2 into 4 multiplied by 1, and that is equal to 8 inch Q. So Q is equal to 8. I is also 8 cubic inch. I was 21.33 inch power 4. This is the value. So now you have all the value, you can just put it. You will get Q is equal to 178 into Q is 8 divided by I is 21.33. And when you calculate it, it will be small q will be 66.67 pounds per inch. This is the shear flow. Horizontal shear force per unit length is called shear flow. Now we know that Q, which is horizontal shear force per unit length, which is the spacing, is equal to shear flow. So we are interested to find out S. So S is equal to FH over Q. So horizontal shear force per unit length are resisted is 800. So 800 divided by Q is 66.67. And that will, when you solve it, will give you 12 inch. So spacing between the nail is 12 inch. This is the maximum spacing. So this is the answer of part first, and this is the answer of part second. And that was all about problem 11-54. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it, and don't forget to press the bell icon so that you can get notification about latest video. If you have any question, you can ask me in comment section, and do comment for your feedback regarding my videos. Thank you for watching.